So here's some basic shop math. Let's start with circumference of a circle. It's either pi times the diameter or 2 times pi times the radius. So 2 times the radius times pi. So say you know the diameter, or the radius, you just solve it. You just plug in your numbers there and solve for the circumference. If you know your circumference, you've got to solve for, let's just take circumference equals pi d. So I know the circumference. I'm going to divide pi out of both sides, and then that circumference divided by pi equals my diameter. When I got a bandsaw, I didn't know what the blade size was for it, so I took the circumference and solved for that, and then I knew what diameter bandsaw blade to buy. So that's very handy. So RPM. Say you want to find out what your spindle on your drill press is running. You got to find the ratio of the pulleys. So the driven diameter, so the diameter of the spindle pulley divided by the drive diameter equals your ratio. So say our drive is 2 inches and our driven is 4 inches. You take driven divided by drive, so 4 divided by 2, there's our ratio. So we take our RPMs divided by the ratio equals the RPM on the spindle or the driven pulley. If we flip those around, so we take the driven divided by the drive again, 2 divided by 4 equals 0.5. So that same 1750 RPM divided by 0.5 equals 3500 at the driven end, at the shaft. So that's pretty helpful, and this will also come into play in surface feet per minute. So say if you have a belt sander that has step pulleys, so it has a motor with a step pulley running a second pulley that runs your drive wheel for your belt. The page before, you'll have to figure out what that actual RPM is at the driven pulley at your actual drive. So surface feet per minute is pi times the drive diameter times the RPM. That will give you an inch per minute. So then an inch per minute divided by, 12 inches per 1 foot, that's our feet per minute. And you could divide it, again, to figure out your miles per hour if you felt like it. So my belt grinder, the original one I built, pi times a 4.5 inch drive wheel, 3600 RPM motor divided by 12. That's my surface feet per minute. So that's helpful. I could probably up that because most of my belts, they'll probably do better at 5,000 feet per minute. But it does all right. So hydraulic calculations for a press. You take the area of the piston. So an area of a circle is pi r squared, or its area equals pi times the diameter squared divided by 4. Take your PSI that the pump is putting out times your area. That will equal your pounds of force, because pounds per square inch. Then divide those pounds by 2,000 pounds in 1 ton. There's your tonnage. The upstroke is different because you lose area because of the shaft diameter. So you've got to find the area of the piston minus the area of the shaft, and then do the math the same way, and you'll find your tonnage on your upstroke, which will be, it'll be less than on the downstroke. One last one. This is a very basic trig. I had a die set a month or so back that I had to build, and they gave me something like this. These are different numbers to make it easier. I know the length of the dies. I know what the opening is supposed to be on either end. So it's basically a taper with a set dimension at either end across this dimension. So I take half of that. Well, I can't really use that still because it doesn't go to 0. That's going to be hard to find my angle. So I make a triangle that starts at 0 on one end. So I take, that 0.25 minus, take it away from that dimension. So I got 0.25 at that end, 2 inches long again because of the die length. These are your trig. So SOHCAHTOA, sine, cosine, tangent, and it tells you what you do with this triangle. So if I want to find A, the angle of that, I take opposite over hypotenuse. Well, I don't know the hypotenuse yet. Adjacent over hypotenuse. No, I don't know that. Tangent, opposite over adjacent. Okay, I know opposite over adjacent. So tangent of A is opposite over adjacent. Basically, you divide tangent out of either side, so you got a tangent inverse times the opposite over the adjacent. So I've got an angle of 7 degrees. And you can check your math on that. It's approximately 7 degrees. This angle and this angle will equal 90. So you take 90 minus 7, you know this angle, and solve the same thing and see if your math works out. That's really, really a basic overview, but hopefully that helps a little. Thanks for watching.